Good morning, all. Myself, Rajit TJ, Assistant Professor, Department of Civil Engineering, Vidyavardaga College of Engineering, Mysore. So, I welcome all of you once again for the session 1 of our day 15 GATE training program. Today, the session will be on engineering mathematics by Professor Shwetha H T. Professor Shwetha H T, working as Assistant Professor in Department of Mathematics in Vidyavardaga College of Engineering, Mysore, having over 7 years of teaching and research experience. She obtained her master's degree from Mans Gangotri University of Mysore and presently pursuing her PhD under the guidance of Dr. N. Bhaskar, head of the Department of Mathematics, VVC Mysore. So, her area of interest is number theory and probability and statistics. In today's session, she will be speaking on engineering mathematics pertaining to GATE 2021. So, with this note, I request Professor Shwetha H T to take over the session. Over to Shwetha H T, madam.
Thank you, Rajit sir. Good morning, everyone. Okay. So I welcome you all to the second session of Engineering Mathematics for GATE. Okay. We'll start with the Laplace transform. So the definition of the Laplace transform actually is consider a function f of t and the Laplace transform of f of t is some. You will get the solution and we will denote it as f bar of s. Okay. And we have the definition, few standard results on this Laplace transform. So they are asking only, as I know, I have seen the previous question papers, they are asking only the standard results actually. So these are the standard results. The function is, this is f of t, which are nothing but the functions. So when the function f of t is a, the Laplace transform is a by s. Okay, or a is anyway constant. If it is 2, it is 2 by s. If it is 1, it is 1 by s. So a is constant. Laplace transform of a is a by s. Next, Laplace transform of e power at is 1 by s minus a. Okay, this power constant a value, whatever, e power 3t means it is 1 by s minus 3. If it is e power minus 3t, a becomes minus 3. So here the Laplace transform becomes 1 by s minus of minus 3, that is s plus 3. Okay, so Laplace transform of e power at is 1 by s minus a. Then we have Laplace transform of t power n. Okay, the fourth one is actually Laplace transform of t power n, where n value is integers, positive integer. If it is positive integers, the Laplace transform is, it is n factorial. So here the power n. Okay, so n factorial by s power n plus 1. If it is just t, find the Laplace transform of t, it becomes 1 factorial, which is 1 by s square. If it is t square, it is 2 factorial by s cube and so on. Okay, this formula holds only if n is positive integers. Other than positive integers, the Laplace transform of t power n is gamma of n plus 1. This is gamma of n plus 1 by s power n plus 1. So for both t power n, whatever may be the n, you can see the denominator. Denominator is same, that is s power n plus 1. So here n means you add plus 1. So it is n plus 1. Only numerator changes. If it is positive integer, it is n factorial. Other than the positive integer, it is gamma of n plus 1. In the next slides, actually, I will tell you what is that gamma definitions also. So next, the Laplace transform of cos hyperbolic at or cos h at. It is h denotes the hyperbolic term. So cos hyperbolic at is, it is s by s square minus a square. Okay, and it is, the next function is cos at. The Laplace transform of cos at is s by s square plus a square. You observe these two cos terms. So it is almost same. The numerator is s and denominator we have s square and a square terms. But if it is hyperbolic, it is negative in the denominator. And if it is just the trigonometric term cos 80, then it is plus. Okay. Similarly, in sine hyperbolic 80, it is a by s square minus a square. You can see all four, the denominator is same. S square, a square, s square, a square. For hyperbolic terms, cos hyperbolic, sine hyperbolic, it is negative. S square minus a square, s square minus a square. For cos 80 and sine 80, it is s square plus a square, s square plus a square. It is easy to remember actually. Then for sine terms, the numerator is a. Okay, if it is sine hyperbolic 2t, it is 2 by. So similarly, sine 80 is a by s square plus a square. For cos, it is numerator is s. For sine, it is a by. Okay, these are the standard formulas. This is more than enough to solve the problems on Laplace transform, and we should know properties. They are not asking the problems on properties. They are asking only the standard result. What is the Laplace transform of cos hyperbolic 80? Okay. Yeah, this is what the definition of gamma function I told you here. See, the Laplace transform of t power n is gamma of n plus 1. So the definition of gamma is gamma of n is, it is n minus 1 into gamma of n minus 1. Okay. Gamma of 3 is 3 minus 1, which is 2 into gamma of 2. And we will continue similarly. We will expand once again gamma of n minus 1 using this same formula. Gamma of n minus 1, it becomes n minus 2 into gamma of n minus 2. Then again, gamma of n minus 2 changes to n minus 3 into gamma of n minus 3. Okay, anyway, this is the basic definition. Gamma of n is n minus 1 into gamma of n minus 1. And if you expand, as I told you, if we keep on expanding this, this is equals to, I'll write it here. This is n minus 1. I can write gamma of n minus 1 by using the same formula as n minus 2. Subtract 1, that's all. N minus 1 minus 1 is n minus 2 into gamma of n minus 2. Again, using the same definition, gamma of n minus 2 becomes n minus 3 into gamma of n minus 3. Again, gamma of n minus 3 is n minus 4 into gamma of n minus 4, and so on. Okay, and that can be written as n factorial. Okay, so n factorial is nothing but n into n minus 1 into n minus 2 into and so on. So this can be written as n factorial. And we have one more standard result, which is nothing but gamma of 1 by 2. It is a standard result. Gamma of 1 by 2 is root pi. So please remember, you can use it directly. So we will use this result, this gamma of n as n minus 1 into gamma of n minus 1 until usually it reduces to gamma of 1 by 2. And we can write finally gamma of 1 by 2 as root pi. So this is the definition of gamma function. So this is the problem, a previous year question paper problem. The Laplace transform of sine hyperbolic 80 is, they are asking just the standard formula. So the Laplace transform of sine hyperbolic 80 is minus s square minus a square. So here a and c are s square minus a square. So b and d are wrong answers. Okay. Then among these two, a and c, it is sine term. Sine means the numerator should be a value, the constant a value. Okay. If it is cos, then it is yes. So answer is a. C is also wrong. So Laplace transform of sine hyperbolic 80 is, it is a by s square minus a square. So answer is actually a. So this is also a previous year question paper problem. Laplace transform of f of s of the exponential function f of t is equals to, this is the given function e power at when t is greater than or equal to 0, where a is constant and s minus a is also greater than 0 is. So simple thing is Laplace transform of this function, they have given t is greater than 0 and s minus a is also positive. So Laplace transform of e power at is, it is 1 by s minus a. It is also a standard result. Laplace transform of exponential function e power at is 1 by s minus a. So B is the answer. Okay. So in the Laplace transform, they are asking most of the question based on the standard formulas. So these are the formulas, standard formulas. Please remember, we have just 8 standard results. Okay. A is A by S, A is nothing but constant, then exponential, T power n is positive integers. For the remaining n, it is gamma of n plus 1. Then if it is cos, it is S by, and if it is hyperbolic term, the denominator is negative. Sine means it is A by, and once again it is hyperbolic term means it is S square minus A square. After this Laplace transform, so I'll start with the next topic, which is differential equations. Most of the problems in GATE asked based on this differential equations. So I hope you know how to solve the differential equations. Anyway, first let me explain. Okay, so in the differential equation, we have equations called homogeneous equations and non-homogeneous equations. Homogeneous equations means if the equations are equal to 0 or the right hand side is 0, that is called homogeneous. And if the right hand side is not equal to 0, if you have some functions, means that is called non-homogeneous. So in homogeneous function, we have to find the solution y, which is called only complementary function yc. Okay. And this is the method to find the complementary function. This is also a standard result. So roots of the auxiliary equation, we have to find the auxiliary equation. We will get the auxiliary equation, simplify those equations, you will get the roots, and we have to find the solution y, which is called yc. C means it is complementary function. That is the solution to the given differential equation. So if these are the roots, they are unique and distinct. Of course, they are distinct. Okay, real and distinct. 0, 1, minus 1, 2, and minus 2. So the complementary function becomes, or the solution is, it is C1 into C1, C2, everything, they are constants. C1 into e power, first root is 0, so it is 0 into x. But e power 0 is nothing but 1. Anything power 0 is 1. So it is 1 into C1 is C1. Plus, again the constant, multiply constant, a second constant I'll take it as C2. C2 into e power, second root is 1 into x, which is x. Plus C3 into e power minus 1 into x, which is e power minus x, plus C4 into e power, the next root is 2, so it is 2x, plus C5 into e power minus 2x. If the roots are real and distinct, this is how we write the complementary function, or the solution actually. Next, if the roots are real and repeated, these are the repeated roots, 3, 3, and they are real. So in such case, the solution or the complementary function is C1 plus C2 into x of e power, root is 3, it is 1 and the same, so just take the 1, which is same as the remaining roots. So e power 3x. If we have one more, for example, 3, 3, 3, okay, then it is the complementary function is C1 plus C2x plus one more term, which is C3 into x square of e power 3x. Okay, so this is whenever the root is real and repeated. Next one is, this is imaginary root. Okay, if the roots are imaginary, then you can see here the real part is absent, which is nothing but actually you can take it as 0. It is 0 plus or minus 2i. Okay, real part is 0, imaginary part is 2. So I will tell you this first. See if it is of the form complex number, means it is of the form a plus ib, or you can call it as x plus iy. X is the real part and y is the imaginary part. So 3 is the real part here and 2 is the imaginary part. So in such case, if it is a complex root, the solution or the complementary function is, it is e power a real root, which is 3. Okay, e power 3x of, and now the imaginary part is 2 of C1 cos 2x plus C2 sin 2x. This 2 is nothing but this one. Okay, so if it is a complex root, the complementary function becomes e power 3x, which is the imaginary part. Then you take the real imaginary part, which is 2, and it is C1 into cos 2x plus C2 into sin 2x. Whereas this one, the real part is 0. So it becomes e power 0x, e power 0 is 1. So it is 1 of imaginary part, or the imaginary value is 2 here. So it is c1 cos 2x plus c2 sin 2x. If the roots are complex or the imaginary, this is how we write the complementary function or the solution to the given differential equation. So these two are one and the same. Here we have both a real, repeated, and also imaginary roots. 1 and 1 are real, but they are repeated roots. If it is repeated, so solution is c1 plus c2x of e power 1 into x. 1 is this root. 1 into x is e power x. Plus the second one is, it is imaginary root. So real part is 1. So it is also e power 1x, which is e power x of imaginary part is also 1. So it is just, here I have taken c1, c2. I'll just continue with those constants. I'll take it as c3, c4. c3 into, okay, please you make correction here. It is c3 into just cos x, not cos 2x. I have copied down the same thing here. So here it is just cos 1 into x, which is cos x, plus c4 into sin x, not 2x, sorry, it is just cos x plus c4 sin x. Last root is they are repeated and imaginary roots in such case. So you take the real part, which is 1. So it is e power 1 into x, which is e power x. Then inside it is same as the repeated roots. It is c1 plus c2 x of, the imaginary part is 2. So it is cos 2x plus c, this is also once again c3 plus c4x of sine 2x. It is same as this one, c1 cos 2x plus c2 sin x. But since they are repeated, these imaginary roots are repeated. In the place of c1, we have c1 plus c2x. In the place of this one, we have c3 plus c4x. This is c3, not just 3. Then, in the differential equation, this is very important to know what is order and what is the degree. The definition of order is the definition is, it is the order of the highest derivative present in the given differential equation. Okay, we have the, you check the highest derivative, and that's its order is nothing but, the definition is itself, it is called order of that given differential equation. So order is nothing but it is the order of, or it is the power of. It is the order of the highest derivative present in that given differential equation. So the next is degree definition. The definition of the degree is, so that is the highest power of the highest derivative present in the given differential equation. In the given differential equation, you check which is the highest derivative and that power. Okay, you can simply call it as the power of, not the highest power. The power of the highest derivative which is present in that given differential equation is nothing but degree. For example, this is the differential equation I have taken, d square y by dx square plus a square x is equals to 0. Here you can see it is d square y. In the given differential equation, this is the highest derivative, which is d square y by dx square. This one. Okay. So it is second order. So order is 2. It is d square y by d square, second order. So order is 2. In this highest derivative, the power here is given is 1. Okay, there is nothing here. If we have d square y by dx square whole square, for example, d square y by dx square whole cube plus a square x is equals to 0, for example. Then this is the highest derivative. So order is 2. Okay. Next degree is, to the, this is the highest derivative and power is 3 here. So degree becomes 3. But here the power is 1. So degree is 1 and order is 2. Order is nothing but the highest derivative present in that given differential equation. And degree is nothing but it is the power of that highest derivative. You check the highest derivative and see what is the power. That is nothing but the degree. Okay, so we have many types of differential equation, linear and higher order differential equation. Linear differential equation means the differential equation is said to be linear if the dependent variable and its derivatives occurs in first degree and they are not multiplied together. Okay. The differential equation is said to be linear if the dependent variable is y and its derivatives, which are dy by dx, d square, or you can call it as y dash, y double dash. Dependent variable is y and its derivative occurs in first degree. Okay, actually order and degree must be 1. So anyway, degree is 1 means okay. And they are not multiplied together means here, for example, means like this, x into or y into dy by dx plus 4y is equals to 2. See, y is the dependent variable and its derivative is dy by dx. They should not be multiplied together. It is not linear differential equation. Okay. So differential equation is said to be linear if the dependent variable, which is nothing but y, and its derivatives, which is dy by dx, occurs in first degree. So for example, dy by dx plus 4y. So this is dependent variable and its derivative is here. So here degree is 1. So, and they're not multiplied together. There is no y here and there is no dy by dx is present here. So this is called linear differential equation. And the solution to this differential equation is, if you get such a function, okay, if you get some function like this is called linear differential equation, where we have to find the solution y. And the solution to this differential equation is, the standard form of the linear differential equation is dy by dx plus py is equals to q. So we have the dependent variable and its derivative, and it is not multiplied together. So usually we get linear differential equation of this form, where p and q are functions of x. Okay, you see this is y is the variable, means p, and it is easy to remember. P and q must be a function of x. We have one more type actually, we can write it in the form dx by dy plus px is equals to q. Okay, in that case, p and q must be a function of y. So here it is, the standard form is dy by dx plus py is equals to q. You can see y here, so it is easy to remember. P must be other than y, so other variable is of course x. So p and q must be a function of x. If it is not a function of x, it must be constant. Okay, so if this is the linear differential equation, then the solution to that linear differential equation is, this is the solution. Solution is y into e power integral p dx. This is actually called integrating factor. Okay, so y into integrating factor is equal to integral q, which is the right hand side, q into integrating factor, which is e power integral p dx into dx plus integration constant c. So you find out what is p and what is q, which are the functions of x, otherwise those are the constants. First you find the integrating factor, if, or you can write the formula e power integral p dx. Then you substitute q and simplify, you will get y. Y is the solution. Of course, you can divide by this term. So you'll just get y is the solution. So this is the solution to the given linear differential equation. Okay. Now, if the given differential equation is not equal to 0, then it is called non-homogeneous. Okay. See, I'll take some function f of x is equals to 0. Okay, this is called homogeneous function. If the right hand side is 0, it is called homogeneous, and we have to find the solution y, okay, which is called yc, complementary function. So that's all, if it is a homogeneous function. If it is non-homogeneous means the right hand side is not equal to 0. You will get some function here. Okay, in such case we have to find out yc, which is called complementary function, and yp, which is called particular solution. Okay, this is extra. If it is not equal to 0 or it is non-homogeneous, we have to find yp. Yc is same as this method. Find the auxiliary equation first. You will get the roots of the auxiliary equation, and I have here it is. If these are the roots, this is what the solution you will get it. Okay, so this is simple in both the case. Only thing is finding yp if it is non-homogeneous or the right hand side is not equal to 0. We have to find the yp, which is called particular integral, and there are many methods to find it. Okay, so particular solution of yp is called actually particular solution of f of d into y is equals to phi of x. Okay, so see, this is not 0 now. This is the equation on the left hand side. Here it is not equal to 0. Here it is a function of x. You can see simply I have taken it as phi. It is a function of x, or I can say what we want actually y. Y is the solution. So what is y? Y is equals to phi of x. You cross multiply, you shift this f to this side. Since it is multiplication, it comes to denominator f of d. So that y can be written as yp. So yp is called, of course, particular integral or the particular solution. Phi of x by f of d. So how to find out this yp particular integral? So there are many methods. If this phi of x is exponential, just the exponential, then this is the method first one. So this yp looks like e power ax. This phi of x becomes e power x after shifting the remaining term here f of d. So it looks like e power ax into f of d. Okay. If it is exponential, the procedure is if you replace this d by this a value. If it is e power 2x, replace d by 2. Okay, it becomes f of 2. Means this is a function, everywhere in the place of d, you will substitute 2. Then you simplify. If that f of a is not equal to 0, then that is the solution. That's all. Okay, it is e power ax by f of a. You can see every d replaced by a. Just replace d by this a value and check whether it is equal to 0 or not. Because if the denominator is 0 it means it becomes infinity. So if this is not equal to 0, it is the solution. If the denominator is 0, then we have to multiply x to numerator. Multiply x to numerator and differentiate the denominator with respect to d, of course. Okay, differentiate this denominator because when you substitute, you are getting 0. So please differentiate this with respect to d. After differentiating, once again, the procedure is same. You have to replace every d by a. Okay, so it becomes f dash of d changes to f dash of a. And once again, you check whether it is equal to 0 or not. If it is not equal to 0, f dash of a is not equal to 0 means this is the solution. Okay. If f dash of a is also 0 means we will continue. That is, once again, to this solution, you multiply x. So x into x becomes, it is x square. E power ax remains the same. And again, differentiate this denominator. So already we have first derivative f dash. Differentiate again with respect to d, which becomes f double dash. After differentiating, replace d by the same a value. And once again, if the denominator is not equal to 0, this is the yp solution. If the denominator is once again 0, the procedure continues that you have to multiply x again to the numerator, which becomes x cube. Then e power ax remains the same and differentiate the denominator once again with respect to d. Okay. So if the right hand side, if in the non-homogeneous differential equation, if the right hand side phi of x is exponential, this is the procedure. Yp becomes, it looks like e power ax by f of d. Then replace d by a. If the denominator is not equal to 0, this is the solution yp. If the denominator is equal to 0, multiply one x to numerator and differentiate this. After differentiating, replace d by a and it will continue. Okay, until you get denominator not equal to 0. So next is if the right hand side phi of x, function of x, if it is a sine or cosine term, okay, then so it looks like sine ax by f of d, or cos, if it is cos term, it is cos ax by f of d. Okay, in such case, so the formula or the method is same for both sine and cos. So it is sine ax by f of d square, cos ax by d square. So here the method is, it is almost same. So sine ax by, you just find out what is a value, which is nothing but the constant. If it is sine 2x, a value is 2. Replace d square by minus a square. Whereas in the first term, exponential, you see, we are replacing just d, not d square. But in the sine and cosine term, we are replacing d square by a square and multiply minus sign. It is not minus a whole square, it is minus a square. And once again, you check whether this denominator is equal to 0 or not. If it is not equal to 0, then this is the solution. If it is equal to 0, then the procedure is same as the first one. Multiply x to numerator or 3 multiply x to this given function, and denominator you differentiate with respect to d. And once again, you replace d square by minus a square. Okay, where d denotes actually differentiation d by dx. So if it is sine and cos, this is the method we use to find the particular integral. Okay, sine x by, replace d square by minus a square. If it is 0, pre-multiply x and differentiate the denominator with respect to d, and once again you replace only d square by minus a square, and so on. The procedure will continue same as the first one. Next, if the right hand side phi of x is polynomial in x, if it is a polynomial like x square plus 2x plus 3, if it is a polynomial, then what is yp? Yp looks like phi of x, which is a polynomial, and we are shifting f of d to this side. So it becomes f of x by f of d, phi of x by f of d, and where phi of x is a polynomial now. So it is the regular method, we have to divide, that's all. Divide phi of x by f of d. But the condition is, before dividing, we should write phi of x as descending powers of x. Okay, decreasing order of x, descending powers of x, and the denominator f of d in ascending powers of d. So here it is increasing order. So numerator is decreasing order and denominator is increasing order. Okay, then only you just divide them. After dividing, whatever the quotient you get, that is nothing but the particular integral or yp, the solution. Okay, but remember, remainder should be equal to 0. You make remainder 0, then you see what is the quotient you are getting. The quotient is itself the particular integral. So if it is a polynomial, it is not the method. You are just dividing by regular method. The only thing is you should change the order. Phi of x should be in the descending order, and the denominator f of d should be in the ascending powers of d. Next one, if the right hand side phi of x, if we have, see, you can see we have exponential along with this v. It is actually function of x. The first case, you can see here it is just the exponential. So this is what the method we use. Along with this exponential, if we have some other function of x, e power ax into sine 2x or e power x into x square. Okay, if we have some function of x, in such case the method is, it is e power ax into, that numerator remains the same. We replace d by d plus a. You just find out what is this a and replace d by d plus a. See, we replace d is replaced by d plus a first, and then find what is v by d plus a by using same as the first case. Okay, we use this method once again, means that turns to these methods, and you find out the solution by using the same method. So along with the exponential, if you have some other function of x, means the thing is you have to replace the denominator, we have to replace d by d plus a and follow the same methods, previous method. Okay. These are the few things when the given equation is non-homogeneous. These are the methods to find the particular solution. And there are some other methods which is called method of variation of parameters. Okay. So in this case means we will get the function other than sine, cosine. Here we talked only about exponential. If the right hand side is exponential, sine term, cosine term, or if it is a polynomial means x square plus 2x. Here it is e power 2x plus some x or sine. We will get function other than these also. For example, secant, tan, something like that. Here we have not explained in such a case. So we use this method. That method is called method of variation of parameters. So what we do is, here I have directly started with yp, but you have to find out yc, which is the complementary function. It is same. So I have not written. After finding yc, you should find yp. And method to find yp is, it is in yc you will get cy1 plus cy2. C1, C2 are nothing but constant. We replace C. Before finding yp, usually we find yc, complementary function. So you will get a function as C1 into some function plus C2 into you will get function. Okay, that we are replacing by A into y1 plus B into y2. These are the functions. C1, C2 is replaced by A and B, capital A and B. Okay, this is the formula or the method to find yp in this case. If the right hand side is other than exponential, sine, cosine, if such form. So what we do here is, here the unknowns are just A and B. We have to find out by using these formulas. A is minus integral y2, you will know, you just substitute y2. Phi of x is nothing but the right hand side. Okay, if it is like some equation is equals to secant x or tan x, so that is phi of x, the right hand side. Some f of x is equals to some differential equation you have here is equals to phi of x. It is not 0, it is equals to some function, so it is called non-homogeneous, and we are finding the solution. This phi of x comes here. So A formula is minus integral y2, you just copy down, phi of x is the left hand side, by w into dx plus integration constant c1. So what is this w? Which is nothing but it is called Wronskian, and the formula to find that w is, it is y1 y2, it is nothing but the determinant of, which is nothing but the same thing, y1 y2 dash minus y2 into y1 dash. This is nothing but, you can write like this also, this is equals to determinant of y1 y2 and its derivatives, y1 dash y2 dash. When you simplify, it is one and the same, y1 into y2 dash minus y2 into y1 dash. Okay, however you want to write it, it is 0. It is called Wronskian. So this is the formula to find w. You have to find out. Substitute everything, simplify, you will get A, and we have to replace that A here in the place of yp, in the place of A. Then the formula to find B is, it is integral y1. Okay, just copy down, you have to copy down from the problem. Y1, phi of x is nothing but left hand side, by w, you will find out anyway by using this formula, which is called Wronskian, into dx plus this is integration constant. Okay, so you find out A and B using this formula and you substitute here, that gives yp or the particular solution. Okay, we will use this method if the left hand, this right hand side is, if it is other than what I told in the previous slides, other than sine and cos, exponential, and fourth one is exponential, it is multiplied by some function. If you get some other function other than these above slides, like secant x, tan x, cot x, then you have to use variation of parameters. Only thing is, write yp right directly like this after finding yc, and you find out A and B using this formula. Next, we have one more method called Legendre's linear equation. Okay, the definition is an equation of the form a naught of ax plus b whole square into y double dash plus a1 into ax plus b. You can see it is power is 1 into y dash, which is dy by dx, plus a2 into y is equals to some function of x, phi of x. It is called Legendre's differential equation. It is easy to identify. We have y, which is the dependent variable. Its derivative is dy by dx. Okay. Here we have d square y by dx square. So degree is 2, order is 2. Here also we have 2. Here order is 1. Here also we have 1. Here it is 0. So here also ax plus b power is 0. If you get such form, for example, 2x plus 3 whole square into d square y by dx square plus 2x plus 3 y dash plus some constant into y is equals to some function of x. If you get function like this, such function is called or such differential equation is called linear differential, Legendre's differential equation. And how to solve this? The solution to this Legendre differential equation is, here we put t is equals to log of ax plus b. Okay, we substitute t as log of ax plus b, or here the base is e. If you take the antilog, it becomes ax plus b is equals to e power t, or e power t is ax plus b. This is the substitution. Remember, if this is the Legendre's differential equation, then we have to simplify to find the solution by substituting t as log of ax plus b. Means here if you have 2x plus 3, it is log of 2x plus 3. So e power t is 2x plus 3. Then after simplification, there is a procedure, no need actually. After simplification, what we do is we can write ax plus b y dash as a into dy. If it is 2x plus 3, so a is 2, so it becomes 2 into dy. That means I will replace it here finally. Similarly, ax plus b, so b is missing here. Is ax, there is b here. Ax plus b whole square y double dash can be written as a square. Find out a, square it, a square into d of d minus 1 into y, and so on. So on means ax plus b whole cube y3 is a cube d of d minus 1 into d minus 2 into y, and so on actually. So these are the standard results. After what we do is, after that we substitute everything in the given Legendre's differential equation. Okay, so this ax plus b whole square y double dash changes to a cube, which is the constant value actually, into d of d minus 1 into d minus 2 into y. This ax plus b into y dash changes to a square constant, d of d minus 1 into y. A2 into y changes to the same, it remains same actually. Then it is exactly same as the differential equation. Take y common and find both yc and yp. The method is same after that. Okay, yc, you find the auxiliary equation, you will get the roots, find out, and similarly you find yp also. But only thing is, you see which equation is given and you have to simplify. We are changing this Legendre's equation into linear differential equation by using the substitution t as log of ax plus b. There is one more differential equation called Cauchy's linear equation. So an equation of the form a naught, a1, a2 are constants, a naught x square y double dash or d square y by dx square plus a1 into x into dy by dx plus a2 into y is equals to phi of x is called Cauchy's linear equation. Y is the dependent variable, its derivative is y dash or dy by dx, degree is 1, x bar is 1. So here it is y double dash or d square y by dx square, order is 2, and here also you can see it is x square. If you have one more term, it is y3 or d cube y by dx cube multiplied by x cube. Okay, if you have such equation, means that is nothing but Cauchy's linear equation. If it is ax plus b, which is nothing but Legendre's, if it is just x square y double dash x y dash, then it is called Cauchy's. So here we will simplify this equation by using the substitution, that is put t is equals to log, here we have just x, so x. The previous, in the place of x we had ax plus b, so replacement is log of ax plus b. The method is same. Then take the antilog, x is equals to e power t or e power t is equals to x, and after simplifying we get the substitution x into y dash as dy. Simply write it as dy, and x square y double dash can be written as d of d minus 1 into y. Similarly, x cube y3 can be written as d of d minus 1 into d minus 2 into y, and so on. So simplify, you will get a quadratic equation or the differential equation, you will get it, and simplify, find both yc and yp. Because it is not equal to 0, it is a function of x, we have to find both yc and yp. And the final general solution y is, it is yc plus yp. Complementary function and particular integral is the general solution y. These are we have few problems. Okay, this is one of the equation dq by dt plus q is equals to 1 with q is equals to 0 at t is equals to 0. Okay, you can see this is of the form. This is nothing but this is linear differential equation. This is of the form dy by dx plus py is equals to q. Okay, this is what I have explained before. This is called linear differential equation. The given equation is of this form. Okay, so instead of y we have q, and instead of x variable we have t. So the solution to this differential equation is y into integrating factor. Integrating factor is actually e power integral p into dx. So this is equals to e power integral. What is p? P given is here, it is 1. Okay, see, it is here, it is variable q means p and q must be a function of t. So t is not present, instead constant we have which is 1. So p is 1 into dx, or you can write it as dt because it is with respect to dt. If you are not comfortable with q and t, solve in the form of x and y, finally you replace it. P is 1 into dx, which is integration of 1 into dx is x, it is e power x. Okay, or in their case the variable x is nothing but t, so it is e power t. Then if this is the integrating factor, the solution is actually y into integrating factor is equals to integral q into integrating factor into dx plus integration constant. What is y? Y is, okay, y remains the same, which is actually q here. I'll replace it later. So y into integrating factor is e power x. I'll change the variable later, is equals to integral. What is q? So q is 1 here, okay, in the place of q. So it is 1. I'll not write it. Integrating factor is e power x into dx plus c. So this is equal to integration of e power x is e power x. So it is e power x plus c. So I just want y here. That is the solution. So what I'll do, I'll divide by e power x throughout or on both sides. So it becomes y is equals to e power x plus c by e power x, or divide separately by this denominator. E power x gets cancelled, it is 1 plus c by e power x, or if I shift it to numerator, it becomes e power minus x. This is the answer, but I'll change the variable to q and t now. Y is actually q. So answer is actually q is equals to 1 plus c. Okay, we have to find out this c also. They have given the initial conditions, sorry. Put q is equals to 0 and t is equals to 0, find out the constant. So both x and y are 0. So here the solution is y0 is equals to 1 plus e power 0. Okay, e power 0 is 1, 1 into c is c. C plus 1 is equals to 0, or c is equals to minus 1. Okay, c is minus 1 means answer becomes actually answer is 1 minus e power minus x, since c is minus 1. Now I'll replace the variables as q and t. If you want, you can do it as q and t itself. Otherwise, if you are comfortable with x and y, change it to x and y. So final answer is y is nothing but, you can see here they have given q. Q is equals to 1 minus e power minus, in the place of x, they have given t. So it is t. So answer is q is equals to 1 minus e power minus t. It is, they have given of q of t. Q of t means q depends on the variable t. We write like this, y of x. Y of x is same as y. Okay. So anyway, it is q is equals to 1 minus e power minus t. Okay. This is the answer. Okay. See, only thing is you have to observe which differential equation is given. So this is linear, and solution to that linear differential equation is this one. Y into integrating factor is equal to integral q into integrating factor into dx plus c. Find out what are p and q, substitute, find the integrating factor, simplify, you will get the answer. Also, they have given the initial conditions, that is just to find the constant, integration constant. Okay. Next problem, consider the ordinary differential equation ODE x square into d square y by dx square minus 2x into dy by dx plus 2y is equals to 0. Given the values of y of 1 is equals to 0 and y of 2 is equals to 2, the value of y of 3. We have to find out y of 3 now. You observe, first you have to check which equation is given. So the equation is x square into, I can write d square y by dx square as y double dash minus 2x into y dash plus 2y is equals to 0. Okay, you see this is nothing but this is Cauchy's Legendre's equation. See, we have y double dash x square, y dash there is x. So this is nothing but that is Cauchy's Legendre equation, Cauchy's equation. So if this is Cauchy's equation, then the substitution is, we have to simplify, that is put t is equals to log x, or x is equals to, if you take the antilog, x is equals to e power t. So we will replace x into y dash, this x into y dash by dy, and x square y double dash by d of d minus 1 into y. So replace it. So it becomes, I'll simplify directly, it becomes d square minus d, okay, of y minus 2 into x into y dash can be written as dy plus 2y is equals to 0. If you take y common, remaining is d square minus d minus 2d, I'll write directly minus 3d plus 2 of y is equals to 0. Okay. Then we have to find the auxiliary equation, that is equate d square, sorry, this is minus 3d plus 2 is equals to 0. This is called auxiliary equation, or some of them will write it as m square. They'll just replace d by m square minus 3m plus 2 is equals to 0. So when you simplify, you will get the roots as 1 and 2. Okay, simplify this equation, quadratic equation, you will get the roots as 1 and 2. You can see the root, they are real and distinct. So therefore, I can write the solution, which is the complementary function yc as c1 e power x plus c2 e power minus 2x. Okay. Then we have to find out yp also. No, just we have to find out yc. Yp is not there because it is equal to 0. The right hand side is 0. It is a homogeneous function. So we have to find out only yc. So answer is yc is equals to c1 e power, the variable is t here. So it is c1 into e power t plus c2 into e power minus plus 2t. Okay, the variable is changing x to t now. So c1 into e power t plus c2 into e power 2t, or c1 into, I can write this as, what is e power t? E power t can be written as x. So c1x plus c2 into e power 2t can be written as e power t whole square. It is one and the same. E power t is x, so it becomes x square. Okay, so this is the solution. But this is the solution, but they have given the initial conditions and we have to find out what is y of 3. So to this solution, put y of 1 is equals to 0. That is x is equals to 1. I'll take this first condition, put x is equals to 1, y is equals to 0 here. Y is 0. So we get the equation 0 is equals to c1 plus c2. We are getting the equation. I'll use the second one. Put x is equals to 2, y is equals to 2. So 2 is equals to 2c1 plus 4c2. And we have to simplify this equation. Okay, simultaneous equation to find out the constants c1 and c2. When you simplify this simultaneous equation, we get c1 is equals to minus 1 and c2 is equals to 1. Okay. Substitute C1 and C2 in this final answer. So answer is yc is equals to what is c1 minus 1. So it is minus x. C2 is 1. So it is x square. Okay. This is a solution, but we have to find out y of 3. Put x is equals to 3. It is actually y of x. If you want, you can write it as y of x or simply y. So what is y of 3? Put x is equals to 3. It is 3. So 3 square is 9. 9 plus 3 is, it is 12. Okay. So, oh, this is minus 3. Sorry. This is minus 3. There is minus x because C1 is minus 1. There is no plus. Minus 3 plus 3 square is 9. 9 minus 3 is 6. Therefore, the answer y of 3 is. So final answer y of 3 is 6. They have given y of 1 as 0, y of 2 as 2, and we have to find out y of 3, and y of 3 is 6. Okay. So first you have to identify the given differential equation. That is the important one. So this is Cauchy's. According to that, the solution is the substitution first. Put t is equals to log x. Simplify. Since the right hand side is 0, it is homogeneous. We have to find only yc. Find out yc using these initial conditions. Find out the constants c1 and c2. Substitute everything. Find the solution. To that solution, put x is equals to 3 and you find out what is y. So here we are getting as y as 6 when x is equals to 3. Okay, next question is, an ordinary differential equation is given below. Dy by dx of x log x is equals to y. The solution of the above equation is. Here we simplify by using variable separable method. We have to separate the variables. That is, I can write the given equation as dy. I'll shift this y to left hand side, so it comes to denominator dy by y is equals to, shift everything to that side, so dx goes to numerator, x log x comes to denominator, it becomes x log x. Okay, and simplify. We have to integrate now. Integrate on both sides. So integration of 1 by y is log y is equals to, here to integrate, I will take 1 by log x as substitution. Put 1 by log x is equals to some t. Differentiate. So differentiation of 1 by log x is, it is differentiation of log x is 1 by x into dx is equals to dt. Okay, so we have 1 by x into dx, which is dt. The remaining 1 by log x, we have taken it as t. So integrate it. Integration of 1 by t is log t. So it is log t. So log y is equals to log t plus some integration constant c. But instead of taking c, I'll take it as some log k. Because it is easy to simplify, log gets cancelled. Log k is nothing but integration constant. Instead of taking c, I'm taking log k. So simplify now. Log y minus log t is equals to, or you can write it as log y is equals to, this is log a plus log b is log a into b, k into t. So here log gets cancelled, y is equals to t into k. But what is t? T is 1 by, okay, t is nothing but log x. Okay, I'm just substituting once again t as 1 by log x. So this is equals to k into log x, 1 by log x. So y is equals to, what is the answer? Answer is y is equals to t into k. T is nothing but 1 by log x. 1 by log x into k. K is nothing but, of course, the constant. Okay, give me a minute, I'll come back to this. Anyway, we'll go to next problem now. The next problem, the solution of the equation x into dy by dx plus y is equals to 0 passing through the point 1, 1 is. So this is the equation. Once again, we have to check the given equation. This is also linear differential equation, but we have to rearrange. I can write the given differential equation as, I just want dy by dx, so I'll divide throughout by I'll divide throughout by x here. So it is dy by dx plus y by x is equals to 0 by x is 0. Now this is of the form dy by dx plus py is equals to q. Okay. So what are p and q? P is equals to, other than y, or p and q are functions of x actually. So p is 1 by x and q is equals to 0. First, we have to find the integrating factor, then I'll find the solution. Integrating factor is e power integral p dx. E power integral p is 1 by x into dx. So e power integral integration of 1 by x is log x. E power log x can be written as x. So this is integrating factor. Therefore, the solution is y into integrating factor is equal to integral q. Q is 0. So it is completely 0 plus some constant c. So x into y is equals to c. But we have to find, they have given the initial condition, that is to find the constant value. Both are equal to 1. Put x equals 1, y is equals to 1. So c value is equals to 1. Therefore, the solution is xy is equals to 1. But we want only y. Y is the solution. So y is equals to 1 by x, or it is, when it comes to numerator, it is x power minus 1. Therefore, the solution is c, which is x power minus 1. Okay. Now the previous problem here, is it? Yeah, here actually the substitution is wrong. We have to take just log x. Okay. Not 1 by log x, you have to take log x as t. Here, okay, this is what we get. We have to integrate. Here we integrate is will be log y, but here you put log x is equals to some t. So differentiation of log x is 1 by x into dx is equals to differentiation of t is t. So now I can simplify. Integration of, okay, I'll write it as it is. Dy by y is equals to integral dx by x. Dx by x can be written as dt. This one, dx by x. And it is, in the denominator, we have log x. Log x is nothing but t. Integration of integration of 1 by y is log y is equals to integration of 1 by t is equals to log t is equals to some constant. I'll take it as, instead of taking as some constant k, I'll take it as once again k, or log y minus log t is equals to log k. Log k minus log b is log a by b. Log y by t is equals to log k. Okay. Then y by t is equals to k. Y is equals to t into k. So y is equals to t is nothing but log gets cancelled. See, it is easy to cancel the log. So instead of taking the integration constant simply as some c or k, I'm taking log. So shift any one of the term, or you can use here itself. Log a minus log b is log a by b. Log gets cancelled. We are getting y by t is equals to k, or y is equals to tk, because we want only y on the left hand side. That is the solution. So I'll just replace it once again. What is t? T is log x. Therefore, y is equals to log x into k, or k into log x. So answer is, yeah, fourth one. So y is equals to k into log x. Okay. So here I did wrong actually. We have to take log x as a substitution, not 1 over log x. Anyway, the method is here. We used this variable separable method. Just separate the variables and then integrate it. We have one more problem. The solution up to 3 decimal places at x equals 1 of the differential equation. The differential equation is given. These are the initial conditions given to find those constants. Okay, you can see the right hand side, it is equals to 0, which is a homogeneous equation. Just we have to find out yc, complementary function. So the given equation can be written as, you can write directly actually, d square y. D square is nothing, okay. Capital D denotes it is d by dx. D square means it is d square by dx square. D cube means, capital D cube means it is d cube by dx cube. Okay. I'll take y common, remaining is d square plus 2 into d by dx can be written as 2d plus 1 of y is equals to 0. Okay, this is actually first step to solve everywhere. Then you have to find the auxiliary equation. Either you can write it in the same form, d square plus 2d plus 1 is equals to 0, equated to 0. This is called auxiliary equation. Or some of them will write it as m square plus 2m plus 1. Simplify this and find the roots. So this is d plus, I can write d square plus 2d plus 1 as d plus 1 whole square is equals to 0. A plus b whole square formula, or d is equals to it is 1, 1. D plus 1 whole square is equals to 0. So D is equals to minus 1 minus 1. Therefore, the complementary function yc is, it is c1 plus c2x into e power, since it is minus 1, it is minus x. Okay. And they have given the initial conditions to find the constant c1 and c2. Okay. Put y of 0 is equals to 1, that is put x is equals to 0 and y is equals to 1. So 1 is equals to, here x is present, so this is completely 0, e power 0 is 1, 1 into c1 we get c1, so c1 value is 1. To find the next value, they have given the next condition, it is dy by dx, so we should differentiate this first, then I can substitute. Y is equals to, this is what we have, y is equals to c1 plus c2 of x of e power minus x. Differentiate dy by dx is equals to, you can use product rule or you multiply e power minus x, then you differentiate. However you want, you can do it. If I multiply them, then if I differentiate, c1 remains the same. Differentiation of e power minus x is minus e power minus x. Plus, multiply these two and differentiate, it is product rule. First function into differentiation of e power x is e power minus x is minus e power minus x, plus second function into differentiation of x is 1. Now you substitute the given condition. Okay, that is dy by, simplify, dy by d of 0 is equals to 1. Here x is equals to 0 and dy by dx is equals to minus 1. So minus 1 is equals to, e power 0 is 1, so it is minus c1. This is 0. C2 into e power 0 is 1, plus it is C2. C1 is 1. So substitute here, we have the value already. It is 1. So when you shift it, it becomes minus 1. Minus 1 is equals to minus 1 plus C2. So C2 is 0 here. Okay, when you shift it, it becomes plus 1. C1, C2, plus 1 minus 1 gets cancelled. C2 is equals to 0. I'll substitute finally in the given solution. Therefore, YC is equals to C1 is 1. C2, since C2 is 0, this is completely 0 into e power minus x. I can write y is equals to e power minus x. So the solution is, it is e power minus x. But you can see they have given the solution up to 3 decimal places at x equals 1. That means to this solution, we have to put x is equals to 1 finally. So put x is equals to 1, it is e power minus 1, or I can write it as 1 by e. E value is 2.7 something. So 1 over 2.7 is, I have written here, the answer is 0.368 because they have asked just to 3 decimal places. So answer is, or 1 by e value is, it is 0.368. Okay, the next problem. Consider the following second order differential equation. Y double dash minus 4y dash plus 3y is equals to, it is not 0, so it is a non-homogeneous equation, and you can see it is a polynomial. Okay, so if it is a polynomial, the particular solution, they are asking us to find only the particular solution. This is the second order differential equation. The particular solution of the equation, we have to find only yp. So yp is here is phi of x by f of d. Okay, that means it is just by dividing these two. So this can be written as d square minus 4d plus 3 of y is equals to 2t minus 3t square. I can write it as like this: d square y by dx square, y dash is dy by dx plus y, where dy by dx, this d by dx can be written as capital D. This y remains the same. Then take y common, you will, this function differential equation looks like this. This is our f of d, we are shifting. Okay. Now, so this is 2t minus 3t square, this phi of x side, by f of d is nothing but d square minus 4d plus 3. We have to just divide them. But the condition is, before dividing, we should rearrange them. The numerator should be in the descending order. So already we have such form. The denominator in the ascending order. So we shall, I'll divide now. Okay, or I can write it as 2t minus 3t square. Here it is 3 minus 4d plus d square. Here it is, write it in the form of descending. So it is 3 minus 3t square plus 2t. So you just divide them. 3 minus 4d plus d square minus 3t square plus 2t. Okay. So 3 is present. I should multiply here just minus t square. So multiply now. Minus t square into 3 is minus 3t square. So minus into minus, it is plus 4 d of t square. Okay. Minus into minus I have written already. D of t square. I told you already d is nothing but differentiation. Differentiation of t square is 2t. 2 into 4 is, it is 8t. Plus into minus, it is minus d square of t square. D square of t square. D square means it is the second derivative now. So differentiation of t square is 2t. If you differentiate again, it becomes 2. So it is minus 2. Change the sign and simplify. It is plus, it is minus, plus 3t square gets cancelled. So answer is, these are the lengthy problems. They have asked for 2 marks. Okay. The answer is here. It is, I'll continue here. Minus 8 plus 2 is minus 60 plus 2. Okay. So what we have to multiply here? We have 3 and here minus 60. So multiply minus 2t. So 3 into minus 2t is minus 60. Then, okay, here I have to write it. Minus 2t. Minus 2 into 3 is minus 60. Then minus into minus it is plus. 4 into 2 is 8. Then differentiation of t is 1. So 1 into 8 is 8. Then d square of 2t. Differentiation of 2t is 2. Then differentiation, I'll do it here. D square of 2t. I have taken the minus sign already. Okay, I'll write it minus here. So differentiation of 2t is 2. Because it is a second differentiation, differentiation of 2 is constant, which is 0. So change the sign. 60 gets cancelled, it is minus 6. Okay, we are getting minus 6 and here we have 3. We have to multiply minus 2. So 2 into 3 into minus 2 is minus 6. Then differentiation of 2, which is constant, 0. Second differentiation also becomes 0. That's all. Change the sign. So 6 it becomes 0. So quotient is 0. Remainder is 0. So therefore the quotient is, that is nothing but the particular integral. It is minus t square minus 2t minus 2. Minus 2 minus 2t 3t square. Okay. So this is the answer. First one. Okay. See, they have given in the other form minus 2 minus 2t t square. So this is the answer. If it is a polynomial, you just have to divide them. But the numerator should be in the descending order. The denominator should be in the form of ascending order. So it is easy to divide it, but remainder should be 0. Then we will take the quotient as the particular integral. They have asked only the particular integral or the particular solution. So solution is this quotient. Okay. Here is the partial differential equation PDE, second order PDE. Dou square u by dou x square plus c into dou square u by dou y square plus b into dou square u by, okay, this is the first term a, then dou square u by dou x into dou y, then c into dou square u by dou y square. First a, then this is c term, plus it is the function of x, y, u into dou p by dou x, dou p by dou y is equals to 0. Sorry, it is not into 0. It is equal to 0. S. Okay. This PDE is parabolic if this condition holds, that is if b square minus 4ac is equals to 0. You take these constants or the coefficients. Okay. So it should be like this. Don't get confused. I have not a into dou square u by dou x square. Then comes the mixed partial. Dou square u by dou x into dou y. This is second term. Then c into dou square u by dou y square plus this is the remaining term. Okay. Check these coefficients. Substitute here in this condition. If this is equals to 0, the given equation is called parabolic. If b square minus 4ac is less than 0, then it is elliptic. If b square minus c is greater, so here is the gate problem, previous year question paper. The type of the PDE is given like this. Yes, we have to show it is whether it is elliptic, parabolic, hyperbolic, or none of this. So it is based on the previous one. We have to find out AC minus B square. This is what we have to check now. So what is A with respect to X is A, coefficient is 1. B is mixed partial, X dou square P by dou X into dou Y. So A is 1, B is 3, C is with respect to Y, which is 1. So substitute here. So A into C, which is 1, B square is 9. Okay. So 1 into 1, 1, 1 minus 9, which is minus 8. Minus 8 is less than 0. If it is less than 0, see here. If B square minus 4AC is less than 0, then the given PD is elliptic. So it is, answer is elliptic. The given differential equation is elliptic. Okay. So check ABC, check the condition AC minus B square and write it. Okay. So the next problem is for a small value of h, the Taylor series expansion, it is a direct formula. The Taylor series expansion for f of x plus h is. So it is f of x plus h into f dash of x plus h square by 2 factorial, f double dash of x plus h cube by 3 factorial, f of third infinity. Okay, of course the first one is the result, the second one is alternative sign. You can see B and D, they are not the answers because you are getting alternative sign, you will not get it, one thing. And here you can see here in the Taylor series we get factorials, 2 factorial, 3 factorial, n factorial. Here you have just the number 2, 3, 4, so this is also not the answer. So this is the Taylor series expansion of f of x plus h. Okay, this is the answer. Next, which one of the following is correct? This is a standard result actually, you have to identify, that's all. So limit as x tends to 0, sine 4x by 2x, this is same. Okay, only result is different. Then limit as x tends to 0, tan x by x. We know that limit as x tends to 0, tan x by x is 1. It is a standard result. So this is correct. All three are correct actually. Okay, so fourth one is not the answer. Since it is not infinity, D is not the answer. Okay, just half of is correct. Tan x by x is 1. So we'll see the first part now. Limit as x tends to 0, sine 4x by sine 2x. Limit as x tends to 0. So sine 2x we have. The numerator sine 4x can be written as 2 cos 2x into sine 2x. I'm using the formula sine 2a. Sine 2a can be written as 2 sine a cos a. Okay. So similarly sine 4a can be written as 2 sine 2a cos 2a. So that is what I have written. Then sine 2x gets cancelled. Remaining is limit as x tends to 0, 2 cos 2x. Put x is equals to 0, limit cos 0 is 1, 1 into 2 is 2. So this is correct, these two are wrong. So B and C are not the answer, so answer is 1. Limit as x tends to 0, sine 4x by sine 2x is 2, and limit as x tends to 0, tan x by x is 1. So answer is first one. Okay. The next question, Euclidean norm or length of the vector. So actually the formula is equals to square root of, we write everything. For example, if I take ABCD, a square plus b square plus c square and so on. Oh, sorry. So it is just a square, b square, etc. So we want just v means it, since we have square, take the square root on both sides, it becomes a root of. Okay, so the Euclidean norm of the vector here is, it is square root of 4 square plus 2 square plus 6 square. So that is equals to 4 square is 16, 2 square is 4 plus 6 square is 36. 36 plus 4 is 40. It is a root of 56. So this is the answer. Just take the square root of sum of the squares of these elements. That is the Euclidean norm. Next question, let W is equals to f of x comma y. It is a function of two variables x, y, where x and y are functions of t. Okay, it is a function of a single variable that depends on single function. You can see x and y are functions of t. Both depends on single variable. We can write f of t or x of t, one and the same. Then according to the chain rule, dw by dt is equal to, see, w depends on the variables, it depends on the two variables, okay, x, y, and x and y depends on a single variable t. And now we have to find out dw by dt. That means we should differentiate w with respect to t. So that is called chain rule. So it is. So differentiate, the chain rule says differentiate w with respect to first variable x now. Since W depends on both the variables, it is partial differentiation. It is dou W by, take the first variable only, dou X. Then since X depends on T, it is dou X by, sorry, dx by dt. Why? Because X depends on a single variable. So it is the regular differentiation, it is not the partial. So dx by dt plus W depends on the second variable y. So it is dou W by dou Y. Why? Because Y depends on both the variables. So it is partial. Again, Y depends on a single variable T. So it is not partial now. It is a ordinary difference. Dou Y by dou. Okay. This is not the answer. Dou W by, okay. Both are completely partial. Dou W by dou X into dx by dt plus dou W by dou Y dy by dt. Okay, this is the answer. Yeah, the first one itself, it is D. No. See, W depends on both the variables. So it is partial differentiation. The symbol is dou. But these two variables, they have given X and Y are functions of T. It depends on a single variable. So it is not partial. It is the regular differentiation, ordinary differentiation. It is T. So dou W by dou X, but here from here to here it is dx by dt. Similarly, with respect to second variable, dou W by dou Y, again Y depends on a single variable, dy by dt. So this is chain rule. Third one, C, is the answer. Last question. Limit as x tends to 0, tan x by x square minus x is equal to. Okay, there are two methods. You can simplify and substitute the limits, or if you substitute the limits, tan 0 is 0. Put x is equals to 0 here, 0 minus 0, 0. You are getting 0 by 0 form. If you get 0 by 0 form, you have to use L'Hospital's rule in indeterminate. That means you have to differentiate both numerator, denominator separately and substitute the limit. Otherwise, here anyway, I can simplify directly. Limit as x tends to 0, tan x by, here I'll take x common, remaining is x minus 1. We know that limit as x tends to 0, tan x by x value is 1. Okay, so remaining is limit as x tends to 0, 1 by x minus 1. Put x is equals to 0. It is 0 minus 1 is minus 1, 1 by minus 1 is minus 1. So answer is minus 1. You can do it directly like this because we can take x common and we know tan x by x when limit as x tends to 0 is 1. Otherwise, if you substitute limit directly, we get 0 by 0 form, which is indeterminate form. We have to use L'Hospital's rule. That means we have to differentiate both numerator and denominator separately. Okay. With this, I will stop now.
Thank you, Shwetha madam. It was a very informative session. So I request all the participants to join us on day 16 day of our GATE training program on Monday, that is on 14th December at 2 p.m. So on that day, Monday, we have two sessions. One session, first session on steel structures by Professor H T, followed by session 2 on wastewater treatment by Professor at 3:45 p.m. using the same YouTube channel. Thank you all.